All right, so now we are in the final stage of the development of the circuit breaker. So what we will be doing is the implementing the logic for the circuit breaker root. So let's get started on this. So what we have to do now is we created a CB processor, right? And the CB processor will have methods to open and close the circuit and then create a schedule which will start after the given threshold. So the first thing that we would do is initialize the CB processor. So let's first add a logger so that uh, we can use this logging. So I'll just add a logger. Okay, so get logger cb operations dot class. Okay, so now that we have added the logger, we would also require an extra parameter, which is the expression manager to evaluate the data view expression for error, which is this. It has a parameter resolver. So for that, we need an expression manager. So private expression manager. So this expression manager is created by the Mule runtime. So once it's created, I've used the injector annotation. So that will be, if it's ready, available, it will be injected into this operations class. So Control Shift O to organize the import and expression manager from Mule runtime. Okay, so we have this two parameters. Now let's, so now that we have added the expression manager, let's initialize. Before that, let's add a logger info, um, processing started, something. We don't need this logger. Let's just remove this. I'll just initialized processor cb processor equals new cb processor, and let's just give the circuit breaker ID, circuit breaker ID, threshold percentage, then the threshold period, and then the open duration. Okay, so we have the cb processor instance ready. Okay, so we got rid of the compile time error. Now what we want to do is switch the state. So from cb processor we have the get state method. So let's switch this, switch cb processor dot get state. So this state will return us the enum cb state. So it could be closed, error, or open. So based on the state, we will implement our logic. So in case if the state is case could be closed. So if the case is closed, so in that case, what we'll do, we'll call the uh, we'll check if there is an error or not. If there is no error, then we'll do nothing. But if there is an error, then we'll call the closed state error handler. So how do we do that? So when the case is closed, it has to go through the close route, right? Which is the main route. So what we'll do, if the state is closed, it will go through the main route. So main route will return us chain because it's chain of processor. It's a scope. It has multiple processor which are chained. So get chain. Once we get the chain, we can call the process method. And this process method takes two argument. One is for the success and the other one is for the error. So if it's successful, we do nothing. If uh, if it's successful, we just evaluate the expression in that case. And in case if it's error, we'll do the same thing. So let's see what I'm trying to say. So we'll get a result. So we'll use this result. Okay. And then I'll give an anonymous implementation for this function. So what we'll do in this result is once the whole scope gets executed, the idea is once the scope gets executed, when the whole scope gets executed, I want to evaluate this particular expression, which is given in the circuit breaker configuration. This is what needs to get evaluated once this chain is completed, right? So we need to write the logic for the same. So what I'll do is result, I'll get a core event. So whenever the processing gets completed in a particular scope, there will be a mule event, right? And mule event will have everything. It will have the payload, it will have the error and required variables, right? So I am interested in getting the mule event. So it's some sort of hacking that we are trying to do. And let's see. So basically I want the event to evaluate my expression because I want to evaluate in case if it's an error, the event will have error. And I want to evaluate the error expression on that event. In case if the payload has something, I want to get the value from payload, right? So I need the event for this parameter resolver error expression to get evaluated. So how do I do that? So for that to happen, I'll have to use reflection to get the event. So let's try to understand what I'm trying to convey over here. So this result will have all the detail. It will have the mule event as well along with it. And I want to extract the mule event from this result. So what I'll do is I'll create a method for uh, for this to get this event. So this that method has to return me core event. Okay, so core event equals get core event, and this get core event will take in two arguments, result object and the string, I mean the method name, which is event. Okay, now as of now I don't have this get core event method, so I'll create it. I'll go to the CB utility class and I'll create this. So how to do that? We'll use reflection for this. So let me just create a public static method, public static core event. This will return core event, so that is why its return type is core event, and we'll name it as get core event. And this takes object basically, which is the result, and the field name. So string field name. So any class has fields, right? So that's the field name that, and it's event. The field name is event that we are passing. So we need to import this core event. So let's import it. Okay. Now comes the main part. So let's set field equals null and core event, because this I'm setting it outside because this will be part as a part of try catch block. So if I set inside try catch block, I won't be able to return this value. So I'm keeping it outside and I'll assign this inside the try catch. So let's do try. Okay, now field needs to be imported, I guess. That's why it's complaining. So field has to be imported from java.lang.reflect because we are using reflection. And now field equals to, so now we'll assign this field. So what we'll assign is result will have that field. So result.get class, we are getting the class of that result because we are taking it as an object, right? So we'll get the class for that result. We'll get the declared field. So the field is this field we want to get from that class. and I know that field name is event. So that is after some R&D that I realized that the field name was event. Now this field name is private. Now I cannot demonstrate it now because it's quite lengthy process to visualize everything, but this is based on the conclusions that I have derived, and I'm just creating a ready-made code in this video, right? So I know that the field name is event, and I also know that the field is a private field. So if that field is a private field, I cannot create an event out of it since the access is restricted. So I want to break the rules and make it public. So I'll use if condition. If field is accessible, and I've added a not. So if field is not accessible, I'll make it accessible because I need that event. So field dot set accessible true. So I made that field accessible, and then I can have the event. So field dot get and pass the result. So I'll get this field, which is the event field, and I know that field is core event. So I'll typecast it. All right, so it's complaining about event. Okay, let's make it as event. Now this is prone to exception, so that is why I kept it in the try block. Now let me add catch block exception in case if something goes wrong, we'll catch it. So what I'll do is I'll e dot print stack trace, or instead let's add also logger dot error occurred in reflection utility. It's okay, so we'll print e dot get message, e dot get cause. Okay, dot to string. Okay, its method get message is undefined for the type string. Let's just remove it. I just need only one. So let's just print the cause. Okay, now, and something goes wrong, throw new runtime exception. So I'll throw an unchecked exception so that if we don't have the event, there's no point in proceeding further. It just has to break. So we'll just rethrow an unchecked exception. But chances of this happening is quite less. But still, in case if anything goes wrong, we should be safe. Okay. So now, if everything is fine, we should be able to return the event. And we do not have any compile time errors now. All right. So we have written the code for this reflection. So now let's go back to the operations class. Okay. So now over here, is it able to call this method? No. So we want to make a static import. So what we'll do is import static com.resiliency.connectors.utility dot What's the name? It's getCoreEvent. Okay, so we have getCoreEvent. All right, so now we can call this getCoreEvent to get the Mule event. Now in next, if we have to evaluate. So to evaluate this, I'll also create isError function and I'll pass the error expression and the event and the expression manager. And in case if it turns out to be true, if it is error, then CB processor. Why is it not accessible? Okay, let's just fix this compile time error. So for error also, let me just give blank so that we don't face error. So error takes two arguments, error and the previous processor, I mean the last processor that got executed, its output. Just add it. Now it's fine. Now next step is it's complaining about core event. Let me just remove this for timing and clear out these errors. So what is it saying? Core event cannot be resolved to a type. So it needs an import of core event. So let me just import core event. So it's from CB utility. What's the name? Core event. Copy this from here and let's just paste it. Okay, so now we have got rid of that error. Now it's complaining about this isError method. So let's create this isError method. So isError method will help us to identify if there's an error or not. So what we need to do is uh, let's just create this method isError. Okay, so public static is error, and this will take parameter resolver object resolver core event and expression manager instance. So expression manager. So you're trying to keep things generic so that in case if tomorrow this needs to be extended, this utility class can be used right away. So one has to send all this. So isError should return boolean. So the return type will be boolean. Okay. Now I need to import this parameter resolver. Let's import expression manager. Let's import and it returns nothing. So let's return false because it's primitive. We cannot return null. Let's try that. Yeah, we cannot return null because it's primitive. Had that been a boolean wrapper, we should have been able to return it. Okay, that's fine. Now let's create boolean is error equals null and we'll set this later on. So if uh, This parameter resolver, as I have mentioned earlier, this is used to defer the resolution. So now we want to resolve the value. So we'll use this. It will have the expression. So resolver dot get class dot get name. Okay. And if it's an expression based parameter resolver. So this is also the class name has been derived after going through the documentation of the Mule runtime and also through multiple trials and errors. So I know the class name. So the class name is expression based parameter resolver. And if the class name contains this, which means that it is an expression based parameter resolver, we can evaluate this. We can use the expression manager to evaluate. Okay, so I'll just explain it further, but let's code it right now. Is error. I'll assign this to expression manager dot evaluate. It's not boolean. Let's keep it generic because I want the function to be generic. So I'll evaluate and get the expression resolver dot get expression dot get. So it will dot get. I'll get the expression string and then the event and then get value. So this will be an object, but now I'll have to typecast it something like this, boolean. So instead of doing this, I can create another utility function, and I'll tell you why. I mean, if this does not contain expression based parameter resolver, and in case if someone has manually entered a string or something, for example, in this circuit breaker root, if someone instead of adding expression enters a string, true or false as a boolean, in that case it won't be a parameter resolver, right? It will be just a plain string with value. So that is why I'm trying to do this stuff, because otherwise I would have right away evaluated without even checking for this expression based parameter resolver. But it could happen because although there is a default value, but someone might want to directly add a boolean true to it, or add a string true to it, and we want it to be generic. So that's the reason uh, we are doing this thing. Had there been nothing, so if we know that for sure there's an expression coming in, we don't want to give any flexibility, then we can right away use this and then just typecast it to boolean. Or else, since we decided to keep it generic, we are doing this. So again, if it's not the case, is error equals to, what we'll do is resolver dot get expression. It will be basically a string, so we'll just return that string. We need not evaluate or anything. All right, but now it's not boolean, it's an object that we are getting, so we need to typecast it to boolean. So that's, since we are trying to make it generic, it could be possible that it might not be a boolean value, it could be some other value, right? So what we can do, we can create another function and name it as public static resolve primitive boolean, and let's give this an object, and this method will take care of resolving, and it will return a primitive boolean data type. Okay, so boolean resolved boolean equals null, and what we do is if object is instance of boolean, then typecast it to Boolean. So result Boolean equals Boolean, typecasting it to Boolean. Okay. Else, it's probably not an instance of Boolean. So if it's an instance of string, so if someone might have manually entered a string value instead of a Boolean value, string true or false. In that case, we'll make it as instance of string. First, we need to check if it's an instance of string, and if it's true, dot equals ignore case. If that's true, mm, so we need to again typecast it to string. If the object, which is a string, so we typecast it to string, and that string is true, then we resolve the Boolean as true. If that's not the case, resolve it to false. Resolved Boolean equals false, and return this resolved Boolean. Resolved Boolean. Okay, now we'll call this method to get the Boolean value. Resolve primitive Boolean, so that we get rid of this compile time error. So we are sending an object, and that object will be resolved using this method. Okay, and then we return is error. Perfect. So we created three utility method. One is to get the core event using reflection. We make the uh, private field event to public and then get the event so that we can evaluate, right? So this is how we evaluate. What we do is we use the expression managers evaluate method, and evaluate method needs the expression and the event. So that is why we had to get the event. If we go back and if I show you over here, what we are doing is in the chain we are using process is two section. One is the result and one is the error. So in result we first need to get the event because we want to evaluate this error expression with the help of event. So we needed this event, so we went to this error method, we gave all this, and then this expression manager, to evaluate it needs the expression along with the event. So that is why we had to take all this overhead. And again, then when we get the value, it's an object. So since we do not want to typecast it, we before typecasting we need to know what is the type. We have created this method. So in worst case, if someone sends a string rather than this expression based parameter resolver, I mean not sending the data view script itself, just sending true or false a string, we have this particular method to just resolve. So it will hit this condition and just return whatever it is. So that is what we have done over here. Now let's go back and put things back into place. So in this operations, let's proceed. So we need to have uh, a static import for isError as well. Let's add that and change it to isError. Okay, so we have this isError. Now, if this condition evaluates to true, which means that there is an error. So CB processor dot handle error in open state. So sorry, handle closed state error handler. So the state is closed and will handle that error in the closed state. So we are calling it, and then now the main point is to use the callback. So the processing is completed. We got the event now after the processing of the scope the closed root, we got the event evaluated to find if it meets our condition. If it meets a condition, it triggers the other flow, uh, the closed state error handler, and finally we should call callback. Callback dot success because it was successful, and just give the result. So that's it. Now for the error condition, in case if it is an error, if it's an error, but we also want to check if our circuit breaker error condition has been met or not. So even in that case, we need to do the same thing. Uh, we need to use core event, just copy and paste the whole thing. And instead of result, we pass error because this error will have the event now. And then use callback dot error and send the error. So this will be rethrown back to the uh, next means the previous processor, or it becomes a throwable and it will be handled as part of Mule's error handling. Now if this condition is satisfied, one more thing, this is closed state error handler only because the state was closed. Now next thing is, so if we don't implement this callback, in that case what would happen is that we saw previously, right? It would never return any response. So it's important that we add this callback. So if this condition is satisfied, then break so that it doesn't go to the other cases. Now similarly, we have a case for open and error. So in open case, we won't be doing much. So change it as open. So in open case, we have to call the fallback route and not the closed route. So fallback route dot get chain dot process. Now in process on success and error, same thing. So we'll result get result callback dot success. What's wrong? Callback dot success result. And for error situation, we'll have two arguments, error and previous. So we will use this error and callback dot error and just give this error. All right, and then just break. So if it's open, it goes through the open, which is the fallback route. And in case if it encounters case as error, the circuit is in error state. So we'll continue using the main route. So the idea is to just use the same processing. The only thing that changes is the circuit breaker logic. So instead of closed state error handler, it should be error state error handler. Okay, and we'll just logger.info. And for the default state, we throw exception. Logger.info unexpected circuit state. And ideally, this should never happen. But in worst case, if it happens, we have the default. So now the code is pretty much ready. So now the code is pretty much ready, and let's try to do an even clean install. But before doing that, I have added icon to it so that we get rid of the default icon and we have a new icon over there. So yeah, now let's just quickly install it. But before that, let me upgrade the version. So let's change the version to 1.0.2. Okay, and let's do a Maven clean install. Okay, so the build is successful. Now let's go back to the Mule project and update the connector to 1.0.2. Okay, and the new icon is there in place. So let's go back and we see the new icon and everything is the same. What we'll do is go through the main route and change this expression. Instead of error not equals to null, uh, payload contains main. If that's the case, we want it to be eligible to trip. So let's test that out now. Now let's quickly run this application, and here comes the moment of truth. And let's see if it really works. All right, so the application has been deployed and we see the cluster has formed with only one member, which is this machine, and everything looks fine. There's no error as such. So let's check that out if it's working. So let's send a request. It's 8081. Okay, we are getting main root. Let's see what logs have occurred. So it's from CB cluster service. First is from the Mule log, which is received request. Okay, then CB cluster service, upserting state for CB demo apps. So this is the ID and the state is closed. Okay, then it started initializing the partition, cluster partition table arrangement. That this is from Hazelcast. We haven't added this log. Okay, then this mule's log main root, and then since error was detected, the condition that we gave that the payload is coming out of the transform should contains main, and that evaluated to true. So it decided to increment the error. So current state is closed. Error count was 1. Updated request count was 1. So error and request count are same. So it's upserting state as error and it has scheduled a task. And since it was set to 1, it opened the state. If you observe, error exceeded the defined threshold, circuit will be opened, and it opened the circuit after almost 1 minute. So let's just check this. So it's going through the fallback route now. So uh, the circuit, the error started coming at 14:07:58, and uh, the schedule tripped it at 14:08 because threshold period was 1 and the ratio was 100. So one request by one is 1, which is 100%. So that's what happened. And now we see the logs in fallback route. So we are seeing fallback. So after a minute or so, it should again switch back to. Now it has destroyed the PN counter because 1 minute has passed and it restored the circuit to closed state. So now when I trigger, I should get the closed route. So let's try that. So let's trigger, and I'm getting main root. So which means that our logic is working. So now what's pending is to test this out in a two node server which has the same application, which means that I'll have to deploy the same application on the same network so that both are visible to each other, and then try to uh, check are the states matching with each other or not, and we'll see that in the next video. So I hope you have understood what all the coding that has gone behind the development of this circuit breaker, and maybe you would find this useful for your own projects as well. So thanks for watching, and in the next video we'll try to work it out on two different nodes and see if the states are matching on both the machines or not. Thank you.